Blessing all the drought, nigga. When you wake up before you brush your teeth, you grab your scraps, nigga. All the time you get down on your knees, you don't crowd, nigga. For what you heard, God blessing all the...
Okay, for this question, we're asked to evaluate or determine that it does not exist, and then we're given the limit as xy goes to the origin, 0, 0, of x squared plus y squared over square root of x squared plus y squared plus 1 minus 1. Okay, so here I'm going to approach this problem in the sense that we're going to try to evaluate what it is, and if it happens to be undefined in the end, or we can't find an answer or something like that, then it will not exist. We'll just decide that it does not exist. So first of all, if we do try direct substitution, then we would get 0 squared plus 0 squared over square root of 0 squared plus 0 squared plus 1 minus 1. So that would be 0 over 0, which is an indeterminate form, so we cannot do direct substitution. So instead, what we're going to do is actually, since we have that square root on the bottom, we're going to rationalize the denominator. Okay? Alright, so what does that mean? That means multiplying by the conjugate. So limit as xy goes to 0, 0, x squared plus y squared. So on the bottom, what we have right now is an x squared plus y squared plus 1 minus 1. So now what we're going to do is multiply times the same terms. So we're going to keep the terms the same, exactly the same, so like that, but we're going to change the sign in between. So we have a plus 1 instead, and we're going to have to do the same thing on the top, right, to act like we're multiplying by a 1. So that's a plus 1, that's inside the square root, and then a plus 1 outside the square root. Okay, so what happens when we do this? We're just going to have to do a little bit of algebra here. So limit as xy goes to 0, 0 of, on the top I'm just going to keep that x squared plus y squared in parentheses, and then we have an x squared plus y squared plus 1 outside, and then this turns out to be, this is the difference of two squares, so we're just going to square both of them and stick a minus sign in between. Okay, so what we'd have is x squared plus y squared plus 1. This is the square root being squared, right? And then we have a minus a 1 being squared. Okay, so this is going to turn out to be limit as xy goes to 0, 0, of x squared plus y squared times that big square root thing, x squared plus y squared plus 1, and then we also have another plus 1. And this is all over, so this squared gets rid of the square root sign, right? So we just have x squared plus y squared, sorry it's all squished down here, plus 1, and then that minus 1 from over here. So those ones cancel out, and we can notice that we have an x squared plus y squared quantity on both the top and bottom, so we can cancel those out, right? That's a removable whole, actually. So what we're left with, I'll write that on the next slide. So we have the limit as xy goes to 0, 0 for the square root of x squared plus y squared plus 1, and then plus another 1 outside, okay? And you can notice, we will notice that this is actually, this function that we have here, this rewritten form of f of xy, is continuous at 0, 0. So what this means is that we can do direct substitution now. So direct substitution, okay? So what we're going to do is just plug in that 0 and that 0. So we have 0 squared plus a 0 squared plus a 1 plus another 1. And then that'll be square root of 1 plus 1, which is a normal 1 plus 1, which equals a 2. Okay? So that is it. That's it for that limit. We did find, eventually, we found an actual number. So it does exist, and we evaluated it. Okay? So that's it for this practice problems video for limits and continuity in several variables. I hope that helped, and good luck studying.
Know yourself a million times, you don't give a fuck.